Flack math! Give me some math and I'll give you some flack. Flack math!
Number 12. Usually when it asks for the domain, it wants to know what's going to break this function. What's going to break this machine? What can't you put into this because it won't understand what to do with it or whatever. You guys remember what you can't put into a function like this?
Negative number?
Yeah, so you don't want to end up with a negative number underneath the radical, okay? So now it's not quite that simple because it's, you have to figure out what x will make this whole thing negative, okay? So what you could do is you know it has to be either 0 or above. It can be 0 because the square root of 0 is 0, right? So you can say something like this: 4x plus 5 has to be greater than or equal to 0. See what I did there? So it has to be that. Now we just solve for x. So get rid of 5. 4x is greater than or equal to negative 5. Divide by 4. So x is greater than or equal to negative 5/4. So the domain, you can just put a capital D colon, and then x is greater than or equal to negative 5/4. Okay? Anything less than negative 5/4 is going to break that machine. I don't know if these are good or not. Good. Okay, so does that make sense for number 12? So you're just trying to find out what's going to break it. Now, the answer is not anything that'll make a negative. The domain is asking what you're allowed to put into it. So make sure you don't reverse that question. If you said x can't be less than, is not less than negative 5/4, I'll take that because that means the same thing. But don't tell me what it can't be, tell me what it can be, okay? All right, number 13, simplify. So we're just gonna distribute, crossed here, 3 radical 2 times 4 radical 2 minus 6 radical 8. Now, technically we could simplify that radical first because there's a 4 hiding in there, right? Or we could just multiply across and then see what we need to simplify. I think we'll find that we don't have to, it'll be easier if we do it this way. So what's 3 radical 2 times 4 radical 2? So 12 radical 4, well, radical 4 is what? Just 2. Not radical 2, 2. Okay? And then what is this? 18 radical 16. Well, what's radical 16? 4.
Just right? Oh, no, it's just times 4, right?
Yep. So now we got 24 minus 72, which is negative 48. Okay? That worked out pretty well. I'm glad we didn't try to reduce that radical first. I mean, that would have been like 2 radical 2, right? And then 12 radical 2, and then 3 radical 2 times 12 radical 2 is 36 radical 16, or what is that? 3 radical 2 times 12 radical 2, yeah, 36 radical 16, which is 36 times 4. What did we do wrong? What? 36 times 2, yeah. Radical 4, which is 2. Okay, but it doesn't matter if you do it this way or the other way. Just make sure you get the right answer. Now, this worked out nice because all the radicals canceled. But remember, if you are stuck with the radical, you can't just cancel it, okay? Just make sure it's simplified. There's no perfect squares hiding inside of it. All right, you guys good with 12 and 13? All right, let's try 14. It says use elimination. So use elimination if you don't want to. If you want to try to use substitution, which I wouldn't recommend because that looks like a pain to get one of those variables by itself, right? You're welcome to do that though, but if you get it wrong, you get it all wrong. So if you use elimination and show your work, you'll still get some partial credit there. Okay, well the problem here, elimination means try to make it so when you add the equations together, one of the variables cancels. Well, it doesn't. Like this almost canceled, right? If this was a negative 3y, then that would have canceled and then we would have all been happy, right? But it didn't. But we can manipulate one or both of these equations to make it so that when we do add them together, something will cancel. So any suggestions? Elkin?
Could the top row, could we multiply that by -4 and then the bottom by just 3?
Yeah, but I'm just going to say 4 and 3. Why? Because if I multiply by -4, it'll turn that negative, and then when I add it, it won't cancel. But good. So multiply by 4. So if I do that, I'm going to just rewrite it down here. So 16x plus 12y equals -24. So far, so good. And then Elkin said multiply the bottom one by 3. Okay, so I get 9x minus 12y equals -51. All right, do you see why we did that? So doesn't this feel like finding a common denominator when you're adding fractions? It should, because what you're looking for is the least common multiple. It doesn't even have to be the least common multiple. You could have multiplied this by 8 and this by 6, and you would have had a 24y and a -24y. It doesn't matter. As long as you have the opposites, and now when I add them together, these guys are going to cancel beautifully. And then I get 27x equals -75, -20 or 25x. So.
Yeah, that was.
Okay, 25x equals -75 divided by 25. 25 goes into 75 3 times, and so it's a -3. So you're half done. Don't celebrate too quickly. You still have to find y. Now finding y in this case is a little bit more complicated. So you have 4 choices of what to plug that into to find y. I'm just going to pick this top equation here, plug -3 in for x. Okay, so if I get 4 times -3 plus 3y equals -6, so I get -12 plus 3y equals -6. Add 12, 3y equals +6, y equals 2. Okay, don't celebrate too quickly. You will never get these wrong as long as you check it. Check those x's and y's in both equations. If they work in both equations, then that's all you need. There's only one combination that'll work in both equations. Let's see if it works here. 3 times -3, -9, minus 4 times 2 is 8. So what's -9 minus 8? -17. It works. Okay. You guys good with this? All right, good. Let's see here. Solve by graphing. Okay. Again, if you want to solve this in a different way, you can, but if you show a little bit of work, then you can get some partial credit just in case you get it wrong. Okay, so this is number 15. Y equals -2x minus 2. Y equals 3x minus 2. So technically you could use substitution pretty easily. Just substitute that y into the other equation. It'd be fine. But we're going to solve by graphing. Okay, there is a shortcut when it's in slope-intercept form. Are these equations in slope-intercept form? They are. When y is by itself, that's what it means to be in slope-intercept form. Because when y is by itself, all the secrets of the line are on the other side. Okay, the number being multiplied by the x is the slope. And this number is the y-axis intercept. Two separate, they don't have anything to do with each other. So this is not the slope like this over this or whatever. This is just the slope. So if you don't see a fraction, make it a fraction. Okay? So what's the slope of the first equation, the top equation? What's the slope of that?
-2/1.
Yeah, so what does that mean, slope-wise?
So you would go, wait, it's rise, right?
Yeah.
So rise as in, you would go 2 down and then 1 to the right.
Perfect, very good. So down 2, right 1. But where do you start?
At -2.
At -2 on the y-axis. Boom, boom, right there. So this is where we're going to start that. And then from here, we're going to go down 2 over 1, down 2 over 1, down 2 over 1, which technically you could go up 2, left 1. You see how that's the same direction? Well, not the same direction, but the opposite direction. So it's still the same slope. So down 2 over 1, down 2 over 1. And I can go up 2, left 1, up 2, left 1. Oops. Up 2, left 1. So there's where my red line is, right there. Do you see that? Okay, now if you don't use graph paper, if you just use paper like this or lined paper, it's going to be more difficult to find the right answer. So use graph paper. Okay, so same thing here. This time we are, so you probably could have figured this out without graphing it, but this starts in the same place, which means that's where they intersect, which means that's the point they have in common. But let's just follow the rules. This is up 3, right 1. So up 3, right 1, up 3, right 1. This guy looks like this. So your answer is going to be, now this is where a lot of students mess this up. What are the coordinates of that point?
-2 and 0. 0 and -2.
0, -2. So you're used to doing up and down first, right? When you're calculating slope and writing slope, you're used to going up 2 over 1 or up 3 over 1 or down 2. Well, when you plot points, you do the x coordinate first. So it's left or right first. So this is 0, -2. So x equals 0, y equals -2. Or you can just write it like this, okay? Now make sure that works in both equations. It does. So you're good to go. All right, so obviously if they have the same y-intercept, then you already know your answer. It's at 0, comma, whatever that number is. Okay? All right, number 16. This
Wait,
is it.
So you know the -2, like your starting point is
Yeah.
the -2. Could that be a fraction?
Yeah, it
So
could
it
be.
could be like 3 over 1, and that's where you'd start. You would do like
Well, 3 over 1 isn't a fraction, but like 1/3, you could start at 1/3.
Yeah.
And then following the slope, you'd have to go down to like -2/3 over 1, and then go down to -1 2/3 and over 1. So it's kind of a pain to calculate the slope when the y-intercept is a fraction, but you can do it. Just
Is
make
there-
sure you have a ruler
Did
And
you
a-
ever start like not on the line?
on the y-axis. Yeah. So if they give you a point and they give you a slope, but they don't give you an equation, then yeah, you could just go to that point, like 2, 3, and then follow the slope and graph it. Yep. So all you need is one point and a slope. So this gives us a point because it's an intercept form. So it tells us right away where one point is. Okay. We didn't get to a lot of those other ones where if you have 2 points, technically you could graph an equation with 2 points, or you can write an equation because you can calculate the slope between the 2 points. You can graph it and then figure out how much it rises and runs, or you can use the slope formula. Did we talk about that at all? Slope formula, m equals y1 minus y2 over x1 minus x2. Wow. Good fun things to come next year. All right. Number 16, indicate if these guys are functions. So what you're looking for is look for multiple y's for the same x, okay? Also, vertical line test. Vert line test. So if for some reason you've got a situation where that happens, then that is not a function. So not a function. No. Okay, so like if 1 goes to 3 and 1 goes to 4, no. Okay, that's the only thing you're looking for. So let's look up here. 5 goes to 2, -5, different x goes to 2, 7 goes to -4, -7 goes to 4. We don't have multiple x, we don't have the same x going to multiple y's. So what is A? That is yes, that is a function. Okay. All right, what about B? 1 goes to H, B goes to 5. So far we're okay. 3 also goes to 5, which we're okay. Multiple x's can go to the same y, but the same x can't go to multiple y's. But 3 also goes to J. So is this a function? No, because 3 goes to 5 and it goes to J. That's bad. Okay. All right, what about C? So when you see a graph, you can use a vertical line test. So picture a vertical line kind of scanning that. Is it going to touch more than 1 point on that graph?
Yeah.
Where? So it's only touching 1 point, right?
Oh, that way.
1 point, 1 point, 1 point, 1 point. If you did this, the horizontal line, well, there's multiple points that are touching, but that doesn't mean it's not a function. Horizontal lines are okay. Okay, but vertical line, it's only touching 1 point at a time. Do you see that? So that's all you need to worry about. It is a function. As far as what you can see now, it could come back around and do something weird. But as far as what we see up there, this is a function. Okay, so this, I'm just gonna redraw it on here. And then I'm gonna do what I did just for the video here. It's only touching 1 point at a time. So at any point on the graph, if you can draw a vertical line and there's 2 points that it's intersecting, then it's not a function. Okay. All right, does that feel all right? Okay, good. Number 17. Solve. All right. This, you guys remember the clever name we have for this problem? F-bomb. This is an F-bomb problem. That's right. So F stands for fraction. I don't know what you guys are thinking, but it stands for fraction. And so we can drop a bomb in this equation and it will eliminate all the fractions. Okay, it'll have different consequences. It'll make a couple numbers bigger, but it will eliminate all the fractions. So the F-bomb is the common denominator. So what's the F-bomb? 30. So multiply both sides by 30. But here's what happens. Now, if you do that, you're going to get, if you would have just made common denominators, you would have turned that into a 30. So times 6 times 6 times 5 times 5, right? And then you would have all this over 30, and then you have the same denominator. So then if you multiply both sides by 30, it gets rid of that 30. So either way, you can do it however you want. You can get a common denominator first and then F-bomb it. Hi. Or you could just do the F-bomb right now, which that's what we're going to do. I'm so excited to drop the F-bomb. Okay. So this is 30 times x minus 2 over 5 minus 30. See, we're distributing 30 over x plus 3 over 6 equals 60. All right. So now what I can do is I can cross reduce 1 and 6, 1 and 5. So now when I distribute that 6, I get 6x minus 12 minus, this is a negative 5, right? We're distributing the negative 5. It might be better to do something like that. 5x minus 15. Okay, remember that tricky part where if you're subtracting a parenthesis, I was worried that my Algebra 2 students forgot that. They didn't, temporarily. They got something wrong on the next test, but don't tell them I told you that. All right, so now we just have a normal, comfortable equation that we're used to combining like terms, simplifying the left side first, and solving. So that's x minus 27 equals 60. Add 27. X equals 87. Whoa. Let's just make sure that works. Let's plug it into our original equation. 87 minus 2 is 85. 85 divided by 5 is 16. 17. 17. Right? No. Yeah. Right? Okay. 17. 87 plus 3 is 90. 90 divided by 6 is 15. Right? Right. What's 17 minus 15? 2. It works. Okay, so let's try it another way. If this F-bomb thing is confusing to you, well, let's try it this way instead. We are just going to find a common denominator and see if we can solve it that way. But you miss out on the joy of the F-bomb. Okay, so I'm just going to get a common denominator like we used to. So this needs to be multiplied by 6. This multiplied by 6. This needs to be multiplied by 5. So this needs to be multiplied by 5. See what I'm doing here? So then I get 6x minus 12 over 30. And then I get 5x plus 15 over 30, but I'm subtracting that whole thing, equals 2. So now you have common denominators, so add the numerators. 6x minus 5x is x. Negative 12 minus 15 is negative 27. See what I'm doing so far? I just found a common denominator so I can add the fractions. Now to get x by itself, I need to multiply both sides by 30. So x minus 27 equals 60. Add 27, x equals 87. So both ways work fine, okay? So the F-bomb really just takes out this step here of finding the common denominator and doing that. So it's Obviously, you're not multiplying this whole thing by 30 because the 30 will reduce with that 5. So it turns out nice because you can reduce. But either way works. Are you guys comfortable with at least one of these ways? Okay, good. All right, number 18. 3 more, and then I'm done teaching you this year. I'm not really teaching you right now, I'm reviewing with you. What are you guys gonna do all summer without learning new math concepts? So sorry for you guys. Why is that there? Okay. All right, 18. 4-part problem, rock and roll. Okay, so let us try to simplify as much as possible. 72 over 8. I mean, you could say this is the square root of 72 over the square root of 8, and then you can take like a 36 out of there, so you get 6 radical 2 over 2 radical 2, so you get 3. These cancel, and you get 3 there. Or you could divide 72 by 8 first. What's 72 divided by 8? What's the square root of 9? 3. Okay, so sometimes you have to do this because it doesn't give you a perfect square. Like if I would have said 72 divided by 10, then I would have gotten 7.2, and that wouldn't have helped me at all. Okay. All right. Oh, we're just saying whether it's a rational number or not. Well, we did have to do this because look, it looked like an irrational number because it had a radical. Anything that's stuck with a radical, like the square root of 2, is irrational. No, it's irrational. Yeah. But if you can write it without a radical, and not rounding it, like square root of 10 is like 3 point something. No, that's still irrational. This is rational, so I'm going to say rat. All right, what about B? Is that rational or irrational?
Isn't that rational?
That is rational. Now, if you see any decimal on your test anywhere, it's got to be rational. Why? Because it's impossible to write decimal numbers on a test and have them go on forever without repeating. So just a little logistical hint there. If you see any decimal anywhere on any test in the universe, that then it's got to be rational because there's got to be an endpoint. There's got to be a final decimal, unless they put like ... or something weird like that, but that doesn't even make sense. Okay? So whenever you see any kind of decimal, it's got to be rational. Either it repeats or it stops. Okay? So a repeating decimal is rational. You can turn that into a fraction. And we actually learn how to do that in Algebra 2, but that's later in the book, and it's not really a great skill to have anyway, so we don't really worry about it. Okay, so this is rational. That's a rat. All right, anything with the pi in it is what? Irrational. So that's an irrat. What if it was pi minus 3 minus pi?
Well, then it'd be rational.
It'd be rational because the pi's would cancel. Nobody wants to cancel a pi, right? All right, D. Anything with the radical, and you're stuck with the radical. This is the square root of 5. That's irrational. Okay? If it was 3 plus 6, then it'd be the square root of 9, which you can reduce to 3, right? But if you're stuck with that radical, it's irrational. Okay? What about the square root of pi? Oh my goodness, that's terrible. That's irrationally irrational. That's 2 kinds of irrational. That's horrible. Okay. Moving on, number 19.
Find the equations of the line. Okay. So remember, the equation of a line is you need slope and you need y-axis intercept. Okay. So believe it or not, the B is a little bit easier, I think, than A. But let's do A first. Whenever you have a vertical line, what is the equation? X equals 2. So that's the only time you'll have an equation where X equals something instead of Y equals something. Any vertical line is X equals wherever it crosses that X axis. So X equals 2. Okay, so this is, so X is everywhere. Everywhere on this line is 2 something. So every point on this line is 2 comma something, right? 2, 0, 2, 1, 2, 2, 2, 3. So that's another way to remember this. But anytime you see a vertical line, and you can write this down if you need to, vertical line, vert line, X equals something. What if it was a horizontal line? Yep, that's just Y equals something, which makes sense because in slope-intercept form, there's no slope because Y equals 0x plus whatever, wherever the Y-intercept is. And 0 slope is just flat, right? If you ride a bike on a 0 slope, then there's no hill, okay? No hill, no slope. Okay, all right, so let's move on to B. So we are looking for slope and intercept. Well, let's do the intercept first. Where does this cross the y-axis? Do you see it?
-1.
-1. Okay, so this is -1, or you can just say -1. Okay, and then how do you calculate slope again? Rise over run, right? So let's go to that -1. We might as well. And let's go to another recognizable point. Now, the next recognizable point looks, and it might be a little bit hard to read, but I think we can handle it. Yeah. Okay, so it looks like it goes from here to here. Now don't cut through these people's lawns. How do you get from this house to this house? You go north 1 or up 1, and you go right 1, 2, 3. So up 1, right 3. And don't forget that X. So there's your equation of that line. Okay, can you guys handle that? So you need to be able to find out where it crosses the y-axis intercept and then calculate the slope. And you need to know where to put the slope and where to put the y-axis intercept. Okay? Make sure you put the right thing in the right place. So this is, no matter what class you do next year, whether it's Algebra 2 or Geometry, you need to know this. You need to know how to graph a line and read a graph of a line. Okay, no problem. This is the last one we're ending with. Find the volume. How do you find the volume of a sphere?
It's 4/3 times pi r cubed.
Nice. Very good. 4/3 pi r cubed. So find the volume and surface area. So surface area is what? 4 pi r squared. It's like 4 circles, right? Because that's 1 circle and that's 4 of them. Okay, so r is 3. That's all you need to know. So 4/3 pi times 3 cubed. So that's 27. So 4/3 pi times 27. Well, that 27 reduces with that 3. And so we get 36 pi centimeters cubed. So you can leave it like that if you want, or if you can multiply it by 3.14 if you want, doesn't matter. So this is 4 times pi times r squared, which is 3 squared, which is 9. Again, with the same answer. That's so weird. Didn't that happen earlier on this test with the hemisphere? Was that this class? No, it wasn't. Was it? Maybe not. Maybe that was the geometry class. But this, you get like the same number, but it's not the same answer. Because cubic centimeters are very different than square centimeters. Okay? It's just coincidence that that you got the same answer. Now, if I would have had any other radius, I would have gotten different numbers for surface area and volume. But for some reason, this gets the same thing. Kind of makes sense, because if you think about the perimeter of a square or the area of a circle versus the circumference of a circle, when the radius is 2, you get the same answer. You get the same number, but not the same answer. But then 3-dimensionally, when the radius is 3, I guess it kind of makes sense.